Well, we're going to, oh, I forgot what number it is. What number is those guys? 15.7. There we go. So we're going to look at triple integrals using cylindrical coordinates. And essentially it says, look, if you do a triple integral in terms of x, y, and z, when you convert it into cylindrical, the x's turn into this guy, the y's turn into that, and the z's stay put. And instead of being dx, dy, dz, in whatever order makes more sense, it's now still dz, but the x and the y in particular turn into r, dr, d theta. So cylindrical coordinates are good when the floor is essentially a circle. So when you know that the region has got a floor and it's circular in some way, then you are good to go, and it strongly suggests you do cylindrical. It tends to make life easy. So here's an example. Suppose I want to do a triple integral of x squared plus y squared. The region E is a cylinder that lies between here and here. I could virtually draw that shape, right? And at this point here, z would be 4, and at this point here, z would be 1. So what would this shape look like on the floor? Well, it would look like that guy. And I know that guy is a circle radius 5. So that tells me r is between 0 and 5. It's the whole circle. So it's 0 to 2 pi. And z was just 1 to 4. So this is kind of a baby question where generating E was not that difficult. Would you agree? It's pretty much handed to you in a plate. So that's A. So let's see what our fella looks like. Well, the original was x squared plus y squared. And we are going to do theta equals 0 to 2 pi. R equals 0 to 5. Z equals 1 to 4. And instead of x squared plus y squared, we should convert it into r's and thetas. And that one's a very nice one, isn't it? R squared. And then we do dz, dr, d theta. Well, I'm looking at this guy, and oh, do you notice what I missed? Because I just noticed it. What did I miss here?
The extra R.
Yeah, there we go. So, probably don't need this line, but I'm putting it in. Okay, everybody's numbers. That is good news. Is this a variable separable situation? Right, agreed? We can separate this. So what am I going to do? I'm going to do a 0 to 2 pi of 1 d theta. I'm going to do a 0 to 5 of r cubed dr. And I'm going to do a z equals 1 to z equals 4 of 1 dz. Does that look good? This guy will get you 2 pi. This guy will get you 3. Oh, how do you know what the integrals of these guys are, the one fellas, without really doing too much? Can you see the short way of finding that this is 2 pi and this is 3 without doing too much extra work to get that? What am I doing to get 2 pi and to get 3?
You're just subtracting one boundary from the other.
Yeah. So if you ever have a situation where you want to do the integral from, well, let's call it a to b of 1 dr, whatever it happens to be, the answer will always be just that. Right, the guy that, say again?
Oh, I was just saying it shows up in the homework sometimes where there'll be like a d theta that just turns into like a 1.
1. And in which case it's just the difference from the start to the finish there. Right, this fella here does require more work. It's that fella evaluated at 0 and at 5. So if I put these guys together, I've got 6 pi, 625 quarters, I believe. Cancel leaves 3. Well, that's not nice. That's 5, 7. I think it's 1875 pi. You can check it later. Are we comfortable with our first straightforward cylindrical coordinate triple integral? Right. So really all we need to do is, practice at it and see what kind of different flavors, little twists that they might or might not spring on you. They don't spring too many twists on you, but they do occasionally. Now, this one is a version of question 5. And essentially what you've got here is, oops, darn it, start again. In this question, what we've got essentially is 2 surfaces. One of them looks like that, and the other is a cylinder. And we are being asked to find the triple integral over this region E. This is where E is. And the thing that we're going to do is e to the z. So far, so good. Any questions? Right. If I put this, maybe I should do that. That's an idea. I don't know if this is going to work. I'm going to try and draw this darn thing so we can get an idea of what it is. Try to figure out, I haven't set this up, so I'm going to have to look for it while I kind of chat away here. Gebra, they should have had a better name. There, I think it's this one. Good grief, I got it. Would you believe it? I actually found it. Right, let's see what this darn thing looks like. It may give us a little insight into what the floor is. Remember, the goal here is to get the floor and to get the range in Z. So if I type in, hopefully it won't do anything weird, Z equals 10 plus x squared plus y squared. For some reason, I'm on capitals. Oh, come on, keyboard. I have to stretch my keyboard quite a distance away because I only have so much desk space, which means I'm stretching over. Right, that looks like I typed it in right. Any idea what that's going to look like when I hit enter?
A cylinder.
Oh, interesting. I don't know what this thing here is. I hope that's not important. I think Geobrew was playing it with me my last time. Okay, where did this come from? Oh, I'm not going to swear because I'm a nice person and I don't like swearing. But I almost did that.
values.
About the 14th time, it's not appearing.
Zoom out, maybe.
Oh, that's a possibility. No. Oh, there the little darling. You're right. I didn't even think of that. Okay, it's like a parabola pointing upwards. Okay. Next guy is a cylinder. So x squared plus y squared. I have no idea where I am right now. Equals 5. I don't like 5, but I'll live with it. Okay. Can you see that the cylinder and the blue guy, which represents those two surfaces, do you see that they meet in a circle? Right, they intersect, they overlap on a circle. Right, if I orientate it, can you see that? Well, that's not very good orientation. There. The circle I'm talking about is where the blue and the red meet. Right, when the cone, when the cylinder goes up and the upturned cup comes down, you see that they, boom, that's where they are. So I am looking for what the floor looks like, because the floor, the XY plane, is going to get me my R and theta. So what do you know about these two guys? Well, isn't that going to be the floor? Because in my picture that I drew, wasn't that going down the way? And then the other thing kind of came in and intersected like this. So I have got my floor. The R value is from 0 to root 5. And the theta value, because it's an entire circle, right? This is the XY plane down here, is 0 to 2 pi. So that wasn't a big deal. I just need to know Z's. Well, I definitely have this fella, right? Agreed? Now, if you can imagine this here being that guy, and this fella here is that guy, right? Z on the floor is 0, and the Z here is this guy. And this guy, I know he says 10 plus x squared plus y squared, but isn't that the same as 10 plus r squared? So Z goes from here to Z equals 0. I'm looking at puzzled faces. Are we good?
What you get with 0 again? Can you?
Oh, the 0 is because it meets up with the cylinder coming up. So Z is 0 coming up. And does it say in the question? I think it says something like bounded. And I'm assuming that I made the assumption it was bounded. I'm trying to find the phrasing that it's got here. Well, question 5. Okay, let's see what how question 5
Yes,
is framed.
Enclosed by the paraboloid.
Yeah. So I'm trying to think why I know it's 0. I know it is 0. I'm just trying to think why I know it's 0. What else could it be? Let's check. No, I'm going with 0. If you set this fella up, then what you're going to get is theta equals 0 to 2 pi. I'm just making the assumption that it's above the plane. And so if it's above the XY plane, Z is 0. It's not a great assumption. Maybe a better idea of why I think that will come to me later.
Okay.
And then it's going to be e to the z, dz, dr, d theta. Are we happy about the circular part, which is this? Right, if you took that shape and looked at what would it do on the floor, right? Yeah, I'm not too convinced about why I said 0, but I'm going for it. So what would that look like? Well, that's actually not that nice. The integral of e to the z is still e to the z. It's going to be evaluated.
Forgotten the R in dz, rdr.
I did. You're right. I did. And there's the R. I put it in that. So I've just integrated this piece. Let's see what that gives me. E to the 10 plus r squared, take away e to the 0, or dr d theta. And that is going to give me well, basically that. Would you agree this is variable separable in the r's and thetas? You agree? I can separate it out as r's and thetas. So I'm going to go 0 to 2 pi of 1 and 0 to root 5 of this, and I'm actually going to multiply it out. Well, this piece here is 2 pi. This is a Calc 2 question. Now, I know how to integrate this fella. It's just a power rule. How am I going to integrate r e to the 10 plus r squared? Calc 2 problem. How do you integrate r e to the 10 plus r squared?
U sub?
Agreed. Who's the u sub going to be?
R squared plus 10.
Okay, so I'm just going to put dot, dot, dot there and off you go and finish it, right? A little unsatisfied about the 0 one, but it had to be something. So when all else fails, I assume they mean from the floor upwards. And so if they mean the floor, it's z equals 0. And the upwards was the equation that they gave us. This one, a little bit different. I want the triple integral of this fella. X plus y plus z. And it's in the first octant. And it lies under z equals 9 minus x squared minus y squared. Now, I could certainly put that in. You'd see your thing coming down. Yeah, it'd look like this thing. I'm not going to be very good at it. I can figure out basically just by this piece of information what everything's going to be. First, z is going to be from 0 to that guy. And it's in the first octant. So in the first octant, isn't z 0 and upwards? Isn't x positive and so is y? So in the z world, you have a surface and you have that. But of course, it's much better to use r. Now, what does this shape look like when it hits the ground? So I need to imagine what this looks like when z is 0. Essentially, I want to find out what that thing is. Well, I can pretty much tell you it's a circle. If I rearrange it, are you happy that it's that circle? Can you see how if you make z equals 0, you're basically seeing what does that shape look like when you cut it on the floor? Because what you cut it on the floor is going to be your xy plane, right? And that's going to be the circle that's going to tell you the r and the thetas. Now, it should be a whole circle, but it's only this piece. And that's because the first quadrant. And since it's only this piece, that's my r's. And we've done quarter circles before. There's my pi upon 2. So this triple integral will now go theta is 0 to a half pi. R goes from 0 to 3. And z goes from 0 to 9 minus r squared. The x is going to become r cos theta. Add the y, which is going to be r sine theta. Plus a z, because z stay put. And a dz and r, because I finally remembered to do an r, d theta. Are we okay about the way I set up that particular triple integral now? Why the z goes from 0 to here, why the r goes from 0 to 3, and why the theta is only from 0 to pi upon 2. Let's take this fella a little bit further then. We have that guy, and we have got that guy, and this is going to be integrated with respect to z. So let's see what that gets you. R cosine theta z plus r sine theta z plus 1/2 z squared. And it's going to be evaluated from z equals 0 to z equals 9 take away r squared, and then we'll do the other things later. So I got 0, pi upon 2, 0, 3. If you replace the z here with 9 minus r squared, you get r 9 minus r squared cosine theta. This one gets you r 9 minus r squared sine theta. And this guy gets you 1/2 of 9 minus r squared squared. Take away, if you plug in z is 0, you just got a whole load of zeros. R dr d theta. We're getting pretty close to the end of what I want to do on this one. There's not an awful lot I can do to make this pretty. In fact, the more I look at it, it looks to me like I'm not going to do much at all, except probably take care of that a little bit and maybe file this out. I'm not even sure I want to do that, but there it goes. 9r take away r cubed cosine theta plus sine theta. So I'm basically multiplying that out and taking it as a common factor. And this horrible mess is 1/2 of 81 minus 1/2 of that fella plus 1/2 of that fella. Oh, good grief, there's another r. R. Okay, I'm getting to the point where I just don't like this question. Isn't it just one big horrible mess of r's and thetas everywhere? So good luck. Now that I'm looking at it, do you think I should do the thetas before the r's? Or should I do the r's before the thetas? Because I can at least switch the order. Just looking at how messy this is, do you think that it makes much difference? Or maybe I should do the thetas or the r's first? Any ideas on the matter? My gut feeling is that there's nothing going to make that question easy. So I might as well just do it in the order and see what happens. I'm assuming that all these 0s and 3s and 0s and 2 pi's eventually reduce that to something nice. According to what I've got here, it's not that nice. That's what it eventually becomes. Well, take their word for it. Okay. This one, I'm just going to set up the E. We've got this fella. We have an X take away Y. And we are told that the region E lies between these two guys and above the plane Z equals Y plus 5. Okay, the key here is above. Maybe that's the word that was missing on the first question today. I'm assuming you're above the XY plane, which it says that. So 0 to this guy. What do those two guys give you when you imagine them on the floor? Yeah. In particular, don't you get a donut? So what does that tell me? It tells me that R goes from 5 to 1, and it tells me theta is everybody. Are you happy about how we constructed from the given information E? I think that one was a bit cleaner. So your integral is going to go from theta equals 0 to 2 pi, from R equals 1 to 5, and from Z equals 0. Now, I'm not going to call this guy Y plus 5, agreed? What do you call Y in polar form?
Or sine theta.
So Y plus 5 becomes that guy. And I'm not going to use X take away Y. I'm going to use R cosine theta, take away R sine theta. And then I'll do dz, and then I'll do R, dr, d theta. Is that question set up enough for you to be able to finish it? You feel comfortable, you know what you're going to do. I'm getting another gut feeling that that's not going to be a pretty question. Would you agree it's probably going to be R's and cosines and sines all over the place? I strongly doubt it's going to be variable separable as well. I wish it was, but I doubt it is. Oh, and according to what I see in front of me, this triple integral is negative, which is okay. It's okay to be negative. It's only if it represents a volume that you need to be much more careful. Now, let's set up what the next fellow would look like. This one's a bit like question 9. I have a surface 10 plus x squared plus y squared. I have a cylinder x squared plus y squared equals 1, and the xy plane. You know, that first question's still bugging me. I've got a feeling they should have mentioned something like the XY plane or above the XY plane, so I could stick that Z equals 0 in, because I am so unconvinced about why it's 0, but it had to be. It just wasn't clear where the information that did this. This does, right? If you're talking about the XY plane, you kind of know where you're going. Now, what we have here is this fella, and the XY plane. Since it's the XY plane, are we happy about the Z values? Of course, won't we turn that into that fella? Now, this shape here is meeting up with that shape there. So I think it's going to be another one of those things that look like that and cylinders coming up and meeting them. But essentially, the floor is going to look like this. And that tells me it's a 1 to 0 circle. And it's a 0 to 2 pi. And of course, I forgot to tell you what the question was. It's a triple integral of e to the z. So it would be theta equals 0 to 2 pi, r equals 0 to 1, z equals 0 to 10 plus r squared, e to the z, dz, dr, d theta. And I am getting real deja vu here. Is that not question 1? The one we did at the start of today?
Guess we were
Almost.
integrating a different function.
Right. This is what I'm thinking it is. So evidently they have little imagination. This guy is going to work. You're going to end up having to do a U sub, and it'll be a bit messy, but it will work. There. The next question, the function that we're dealing with is 8x cubed plus xy squared. Ugh, don't like to look at that. It's in the first octant, which I do like. And the parabola that we're looking at looks like that. Okay, let's see what E looks like. Are you happy about the range in Z is from this guy to 0? And you're happy about the x squared minus y squared becoming this? It's in the first octant, but we don't kind of know what the shape looks like. If you take this surface and you imagine it hitting the floor, then that means Z equals 0. Right? It hits the floor, the XY plane, when Z is 0, and that becomes the circle that we're looking for. So I know that R is going to be from 0 to 2. What about theta? Remember, it's in the first octant. So isn't it only that piece? So we're going to have theta is 0 to a half pi. A lot of deja vu going on today. Eight x cubed. Goodness gracious. that's not going to be pretty. It's going to be r cubed cos cubed plus xy squared, which is going to be one of these and the square of them. So you're going to get an r cubed. You're going to get 1x. And you're going to get square of these guys. And you're going to have a dz and r dr d theta. It's going to be ugly. But it is doable, isn't it? You just, well, what essentially, aren't you just going to stick a Z on all of this? You agree? You're just going to stick a Z on all of this. So couldn't you just leave it as is with one big Z and replace it with this and have some massive foiling thing? Probably be about this big. And then do the R and then do the theta. Superficially, I strongly suspect you won't be able to separate it, which is going to make it even worse because of that. But it will exist. Do you want me to do more of this, or can you just imagine how ugly it's going to be? No, y'all okay, you know it's going to be horrible, so you might as well just wait until you have to do your version. Okay. We got one last guy. We're going to do another center of mass. And just to remind you, there's a formula for calculating center of mass, right? You're going to be given a density function, right? Oops, x, y, z. And the first thing you get is the mass of the object, which will be the triple integral over some region E of the density function, dv. And then we have the x, y, and z bar guys. And they are 1 over m, a triple integral, in each case, 1 over m, triple integral, 1 over m, triple integral. It's kind of an elegant formula. What's the rest of x bar?
X, row X, Y, Z.
And y for y bar, and z. One. I don't know if I've ever mentioned this, so I'm going to mention it now. Do you see this piece of the formula? Pretty much all of the formula, except the 1 over m. This is called the moment. It's very often got a big capital letter. And this is the moment yz. So when you get x bar, the moment is called the moment yz. This fella, just this piece, which is again almost all of it, this is called the moment. And the moment of y is called xz. And for completeness sake, this piece here is called the moment. And the moment of z is xy. Have any of you heard of the term the moments of a solid or a shape of some kind? Is it a term that's ever appeared in any of your physics world stuff?
I remember it from physics.
Right. Does it mean anything? I mean, I'm not a physics guy. Does it mean anything useful, or is it just a name for something? Is it something you would want to know on its own? I guess I'm asking.
Well, it's helpful to just find it because it's kind of like if I remember correctly, it's the point where everything can move around. So if you wanna know if something can be moved around or like twisted around, something like that. So if I remember correctly.
Okay. I as I said, I don't know anything about physics. Not my thing.
Yeah.
Engineering. Guessing that's engineering. So just in case you go watching a movie, a video, and this thing suddenly appears out of nowhere, because if you use this notation, that's X bar. You see how small the formula is? And if you use this notation, that's Y bar. And if you use this notation, that's Z bar. It makes no difference in any way, shape, or form to what I'm about to do. But you might look up at another textbook and you might see these things called moments, and you might wonder, what on earth are they doing? What are these things? That's all it is. It's just a name given to this piece of the formula. And evidently for some people in physics, it's something that they like to know anyway on its own. So I guess there might be situations where you don't want to know the center of mass. You just want to know what the moments are, right? Why you want to, who cares? Right, back to this problem. And we haven't got one yet. So let's tell you who E is. It's bounded. Okay. And it's bounded by Z equals X squared plus Y squared, and a Z equals 63 take away 6X squared take away 6Y squared. Can you imagine one of them looks like this and the other one looks like that, and you end up with an acorn shape, where that might be the top surface and this is the bottom surface, right? So you've got one surface going like this and the other surface coming upwards. So this might be the X squared plus Y squared guy. Actually, pretty sure it's this one. And this here would be the 63 take away that guy. So you can plug that into GeoGebra and see it. Now, I need to know E. I need to know where Z starts and finishes. I need a circle, because it's going to be cylindrical, so I know it's going to be a circle. And the circle has to be the projection of the intersection of these planes on the floor. Right? What the shadow would look like if you were looking vertically above the thing. And because once I get that circle or part of a circle, then I know my R and my theta, and that's me got the polar thing pretty much set up. Oh, and by the way, in this question, the density function is a constant, which means it's just a fixed number k. So we don't have too much to worry about that part. Well, I think the Z is kind of easy, because isn't one of the Z's this guy and the other Z is that guy? And I draw my picture with this guy on top and that guy in below. And if I had it in Desmos, I could look at it and I could say, yeah, the pink one's on top and the blue one's on the bottom. And the pink one was this guy and the blue one was that guy. But I can do a very quick check here. Can I just choose one point? Let's choose 0, 0. At 0, 0, won't this Z value be nothing? And won't this value be 63? So would you agree at the origin, this is bigger than that? So that's how I decided this guy goes there and this guy goes there. Are you happy with the logic of doing it without a picture? Just pick a point. You know it's going to be a circle or part of a circle, right? That's what cylindricals all are. So isn't 0, 0 going to be part of the picture, right? So that's why I chose 0, 0. And it's easy to calculate. Now, I need to know what kind of circle, right? Can you imagine these intersect in a circle? Well, I've got this guy and I've got this guy. How would I find the region of intersection between the two planes?
Set them equal to each other.
Okay, so if I go this guy equals this guy, and I add them to both sides, and I divide both sides by 7, oh, isn't that a nice circle? If you want to know when one thing intersects with the other, don't you put one equation, make it equal to the other, and solve? So we now have r and theta. I'm going to make an assumption that this is actually a whole circle. If you went into Desmos, you would see it was a whole circle. Right. Are we comfortable with how we created the cylindrical version of E? You feel you know where I'm coming from and why I did what I did? Okay, I got a note. So let's get mass. It's going to be from 0 to 2 pi, from 0 to 3, and from z equals r squared to 63. Ugh. 6r squared. At least it's a k, right? So we're not going to do much that way. And it's going to be a dz, an r, a dr, and a d theta. I really think I do need to do this one and then just leave you to your own devices for the rest. So it's going to be 0 to 2 pi, 0 to 3, kz. Evaluate it here. And here. And then I can do the r, d theta. That guy's going to be k times this fella, take away k times this fella. Do you know what? Let's bring this k outside. It's in the way. So I got this guy, take away that guy. It looks like I've got 63, take away 7r squared. And that looks like we've got 63r take away 7r cubed. Oh, good news. Don't we have a variable separable? I'll take it when I can get it. I was hoping that I could get this done because I know your time is valuable. Okay, 63 over 2 r squared, 7/4 r to the 4, evaluated at 0 and at 3. I can't do that. It's going to take too long. It's 42k pi, right? It's not, but I'm calling it that. Can you imagine plugging in the numbers, getting whatever ugly fraction that you get? Now, all you will do then is see to get x bar. Won't it be 1 over 42k pi? And here, you'll stick an x. And the x will be turned into r cos theta. And you'll go through a whole load of working that looks very similar. Agreed? With an extra r and an extra cosine theta. But I'm pretty sure it's variable separable, so that's at least something. And then you do the same with the y bar and the same with the z bar. I'm wondering if there's any symmetry here. Yes, there is. There's an x bar, a y bar, and a z bar, right? That's what we're going to get. The question was set up in such a way that I believe there's a lot of symmetry going on. There is a symmetry in which of the two variables? In other words, they're both going to be the same number. Here's my badly drawn picture of what it might look like.
X and Y?
Agreed. If you look at this shape from vertically above, aren't all the heights consistent with each other as far as X and Y is concerned? So I would bet a bottom dollar that those two guys are going to be symmetric. I am also going to bet another bottom dollar. I'm going to bet they're both 0. Why do you think I can get away with that? Are these shapes semi-symmetric? A sphere is perfectly symmetric. Orientated looking downwards, doesn't this shape just look like a circle? But at any given point, the height difference is the same kind of value. To me, that makes the thing symmetric. And it also tells me that the center of mass for the X's and Y's are going to be at the origin. And you can find that out, but that's my best guess. Z, however, I believe the XY plane is here. I don't know what Z is. It'll be somewhere, here or maybe there. But that one you'll have to calculate because I don't know what that's going to be. So that would be my best guess. Symmetric in X and Y. So if it's not 0, 0, because my gut feeling could be wrong, it's definitely symmetric. I bet money on that. So it's 4/3, 4/3, whatever. And that is us for today. So say hi. I shall see you on Monday. And anybody who has any questions, just hang about and I'll try and answer them. Have a nice week.
See you Monday.
See you Monday. Have a great weekend, everybody. Anna, stop getting drunk and causing fights, okay? So have a quiet weekend this weekend. Okay, we got 3 people, 2 people. Travis, you got a question?
No, I was just.
No,
hanging
you
out.
just wanted to watch. Nothing wrong with that. What you got for me then, G?
So I can just read it to you. It says evaluate the triple integral. Region E 10x dv.
E?
Yes, that's the region. And then E is bounded by the paraboloid x is equal to 5y squared plus 5z squared, and the plane x is equal to 5.
Okay, I'm going to put this up on the white screen and you can tell me what's missing. What goes in here?
So that's 10x.
Okay. So we got this guy and we got this guy. Is that essentially what you tell me?
That is correct. 5y
Okay.
squared, 5z squared,
Right.
x is equal to 5. Yep.
The way my brain is working here is that if you plug 5 into here to see where these two things intersect, what you get
A circle
is a circle. And it's a very simple circle. It's a circle of radius 1. The problem is that this circle is not on the XY plane. Oops. It's in the YZ plane. So the circle is actually here. So it's not on the floor, XY plane. It's in the YZ plane. Well, that's fine. We can handle that. So I think this is a good candidate for polar stroke cylindrical. They didn't call it cylindrical in these questions, but essentially it is.
Yeah.
So in this case, if you're thinking about what you're going to get, you're going to get y is r cos theta, and z is r sin theta.
R sin theta, that's correct.
And you're going to do, if you use that orientation, you can simply just convert what the region, the circle looks like in the usual polar stroke cylindrical way.
Yeah.
X is from 5 to here. So X is going to stay put. It's going to be 5 on one side and it's going to be this guy on the other side. I'm assuming one of them's bigger than the other. If I click the origin, this one's big. And won't this guy actually simplify?
Yeah, that would be 5r squared.
Yes. So my triple integral is going to be from x equals 5r squared to x equals 5, from r equals 0 to r equals 1, and from theta equals 0 to theta equals 2 pi. The function is called 10x, which I'm just going to leave because x's are not the guy that we need to worry about, r dr d theta. And I forgot put in dx.
Oh, dx first, yeah. Okay.
So you're going to get 5x squared evaluated from here to here.
Yeah.
Then you're going to do an r dr d theta using a 0, 1, 0, 2 pi combination.